Hello and welcome back. This is part 3 in our discussion on solving word problems with trigonometry. So let's get started. Our scenario states that a lighthouse is 200 feet high. From the top of the lighthouse, find the angle of depression to the nearest degree of a boat out at sea if the boat is 3,000 feet away from the foot of the lighthouse. So, let's take a look at our little diagram. We have a lighthouse labeled as being 200 feet high, and it's looking out straight ahead. And this is a 90-degree angle. It's a 90-degree angle from the lighthouse to the view straight out ahead. However, there's a boat down below. And in the event that the lighthouse focuses on that boat, then it will be looking down at an angle of depression. And this is an unknown angle. But we do see that the boat is 3,000 feet away from the foot of the lighthouse. So, what we see in our little diagram, when we connect the lines between everything and label it, we realize that the angle of depression that we don't know is the same value as the angle ACD. And this is because the line AB and the line CD are parallel. And they're ulterior, these are called alternate interior angles. These angles, which are both labeled as X, are equal. So basically, if we find the value for the X on the blue triangle, then we should know what the angle of depression is up above that the lighthouse is looking down. So, what we're going to do is ask ourselves, since we have that angle down below labeled as X, and the side opposite that angle is 200 feet, and the side adjacent to it is 3,000 feet, which one of the trig ratios can we use? Well, since we have opposite and adjacent, that's looking like we can use the tan. So let's get the tangent of that unknown angle by putting tan of X, since we don't know it, equals the opposite side, 200, over the adjacent side, 3,000. So we have to figure out what 200 divided by 3,000 is. So we're going to turn on our calculators and do some simple math. 200 divided by 3,000 equals 0.0666. So we're just going to say 0.0667. So tan of the angle equals 0.066, and since the 6's continue, we'll round that last one up to 7. Okay, so we still don't know what angle that is down there, and we need the value because it's the same value as the angle of depression, and we're not there yet. So the problem is we don't know what the angle is. We only know what the tan of it is. And if you've ever looked at a unit circle, it does have the ability to see the sine and the cosine of the major angles and to figure out what the tangent is of the major angles. But if it's one of those little numbers in between, you know, it's not so clear cut. So we're going to use our calculator to find out what that angle is. I want you to click on mode first and make sure that you are in degree mode. If you're not, click down twice and over to the right once to hover over degree and press enter. Exit that menu by clicking second and quit, and now you are ready. Click second and tan, since we're finding the inverse. And then you're going to put 0.0667 0.0667. Close the parentheses and click enter. We have 3.81, which will be rounded off to 4. So basically, our unknown angle x equals 4. And since these are alternate interior angles, the value of this x down here is going to be the same value as our angle of depression. So 4 is our angle of depression. Alright then, let's do another one. The diagonal of a rectangular parcel of land makes an angle of 18 degrees with the longer side. If the longer side is 120 feet, find the length of the diagonal. Round to the nearest tenth of a foot. Okay, so looking at our diagram, we have a little patch of land, and one side is longer than the other because it's a rectangle. So the diagonal drawn in the middle of this makes an 18-degree angle. And so we want to know what the length of it is in feet, because we know the length of the longest side, but we don't know the length of the diagonal. Okay, so looking at this, we can see we have the 18-degree angle. Nothing is labeled opposite it, but adjacent to it, right next to that angle, we have 120 feet labeled for that side, and we have our hypotenuse value as x. So we're going to use the cosine function to find the length of the diagonal. We're going to write cosine of 18 degrees equals 120 over x. Okay, so we are going to multiply x. We're going to multiply x times both sides of this equation so that we can isolate it. So we're going to end up with x times the cosine of 18. I'll write it down here. X times the cosine of 18, or cosine of 18x, equals 120. But we still don't know what x is, so we're going to divide both sides by the cosine of 18. Cosine of 18 divided by cosine of 18 cancels out. X is going to equal 120 over the cosine of 18. So turn on your calculator and let's go ahead and put that in. You should already be in degree mode. (120) divided by the cosine of 18 equals 126. So x, or the length of the diagonal of this rectangle, is equal to 126 feet. And there you have it. Well, this has been fun. I think next we will go over the Pythagorean theorem and how we can use that to solve problems in right triangle trigonometry, and then we'll move over to trigonometric functions that help us solve missing sides of non-right triangles. So we'll be doing the law of sines and the law of cosines and all of that good stuff. So stay tuned. Thanks for watching and have a great day.